I've got one of those at the computer room and stuff. The 50 in one. So well, if you use it as a pry bar and other things, then, you know. Oh, it lasts a decent amount. Here's my ripple when I I got told off that my big bag is hanging.
And my drill.
Yeah.
Ballard here.
Yeah.
I'm just going to yell out your names so I can't figure out who's underneath all the masks. Cody's here. Cody is here, right? Jay. Saw him. He's taking a shit probably. Derek's here. Jeff's here. Jonathan's here. Kyle's here. All right, we can't be too social distancing in here, so don't make out with each other. Okay, especially you. That's directed to you.
Hey Zach, do you have another one of those lab sheets? I brought it all inside last night.
Oh jeez.
My biscuit dog spilled my
What
milkshake all over it.
I had a nickel for every. Is Connor here?
Yeah.
Every time you heard that excuse.
I have a nickel for every time my dog spilled a milkshake on my stuff.
He's a fucking shithead, dude. He's a shithead, I'm telling you.
All right, if you happen to be on a computer and you want to join in on Zoom, I'm having issues getting that to match my computer, so I'm just going to read the questions of the homework, and we'll go through the homework quickly. Talk about push buttons and control relays hopefully today, and then I'll cut you loose on the labs and Pac-Man. If you're not on Zoom, you can always watch this if you need to review for tests and stuff. You can watch this on YouTube later on. Everybody's seen on Google Drive where I'm posting the YouTube videos in case you need to go over something again. You don't care, do you? It's a big giant waste of my time. I know you guys go to work and you're like, I want to watch that class again, right?
Yep. So you don't get all the glory? At least subscribe to us so that you don't get all the glory.
Subscribe?
Yeah.
Sure. What am I subscribing to?
You have a YouTube channel? You can't subscribe to you.
What is your YouTube? What's your handle, or what are you, your Twitter?
It's just Antoine.
At
sitting in,
Antoine.
Like a plain white room talking about life.
And how much
He gives relationship advice.
Antoine, the life coach.
The first step in respecting your girlfriend.
Make sure to spend all your money on her.
Sexual relations make you the devil.
Or she will not give you anything for the rest of your life.
All right.
Don't give her a BB touch.
So what did we do? Chapter 4 was due today?
Yeah.
All right.
Was it?
True or false? A push button assembly can have multiple contact sets. That's true. Emergency stop push buttons must be of the maintained contact type.
True. But in the book,
That's
it
true.
did say most of the time. It did not say all of the time. It said they are usually maintained.
It was a lie.
If I'm putting it in at my workplace, I'm making it maintained.
Yeah, that's what I figured. So that's why
It's
I
just a
went through
safety
anyway.
thing. I mean, if your stop button kills a control relay, you never know if it's got enough. It kills the inductance enough to just maintain it to be safe. And you know the difference? We're going to look at push buttons today anyway, but is this maintained? No, it's a nice mushroom head, but it's not maintained. So maintained means that I push it in, it stays open, and then usually you have to like twist it to get it back out, or some of them have a key in it to close it back again. Are limit switches usually actuated by hand? Nope. Never directly operate a motor with a proc sensor?
True.
True. Why?
Dangerous.
It's not dangerous, but proc sensors have delicate electronics in it. They're not meant to handle the load of a motor, right? Most motors are doing some work, drawing some current, using some horsepower, so a proc sensor is not built to handle all that. Which of the following would be classified as a pilot control device? A starter, a controller, a contactor, or a pressure switch? Pressure switch? That's right. And there's a picture of, I can't show it to you unless you're on Zoom, but the picture for number 6 is a single pole, double throw switch.
Hey, Jack,
What?
for that, so isn't it, so if you got like the same amount of bars on each side, isn't it always going to be a single or not a single throw? And then if there's twice as many on one side, it's going to be a double throw.
So what do you, yeah, the way I think of it is a pole is a line. So if you're using single phase 240, you're going to be switching 2 lines, right? So like on a 240 volt breaker, you turn it on and off, and you better be turning both phases off. That's 2 pole single throw. This is single pole double throw because you're only switching one leg, but it's a common to other 2 points, so it's going like that. And it's showing a 3-way switch is what it's showing. I know you can't see it, but you should remember it from your homework. Number 7, what kind of push button makes a circuit when it is pressed and returns it to the open position when the button is released? Normally open. Like this. It makes when it's pressed. Which of the following would be classified as a mechanically operated switch? A joystick, a limit switch, drum switch, push button switch. Mechanically operated. Limit switch. Do you remember that question that was, do we operate limit switches by hand? The answer is no. It's yeah, please. Thank you. A drum switch, though, you would operate that by hand. Have you guys seen drum switches? I don't think I've ever seen one in the field, but you might see them in your workplace. I'll grab one so you can see what they look like. When a metal object enters the high frequency field of an inductive proximity sensor, what does it do? It increases energy in the oscillator circuit. It causes the object to be attracted by the sensor. A decrease of energy in the oscillator circuit. The object to be repelled by the sensor. A decrease of energy in the oscillator circuit. I believe all 6 of those trainers that you guys are using out there have an inductive and a non-inductive type prox sensor. Which of the following sensors is designed to sense the strength of a magnetic field? Hall sensor, RTD, strain wire, strain gauge, photoelectric. That's the Hall effect. Somebody say that? Which type converts rotational speed into an analog voltage signal? The TAC. The TAC. Which flow meter operates by measuring the changes of induced voltage of a conductive fluid? Magnetic, turbine, target, or differential pressure?
That was the turbine. Yeah.
Magnetic. All right, and then question 13 shows double pull, single throw, correct? If you can see it. So we're switching 2 poles, one action of turning them both on or off. The coil current for an AC solenoid is primarily limited by, did I talk about that the other day?
I feel like it meant, yeah, you dabbled on it.
We dabbled a little bit. So remember when you guys went through all that inductive reactance, capacitive reactance crap? Here's the coil of this motor starter. All this thing is a coil of wire going round and round and round, 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 comes back out. So in, round, 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 comes back out. So if that's one piece of wire and I put 120 volts on it, why wouldn't it trip a breaker? If I had a flat piece of wire and I put 120 volts end to end, not very much resistance, right? The amperage should be enormous. But why doesn't this trip the breaker? Inductive reactance. Remember, inductive reactance is a load, right? It's a resistance caused by the coil. So all that stuff and math that you guys learned in 133 is coming to fruition, right? There was a reason for that. It wasn't just boring. It was kind of boring, but Number 15, the amount of pulling or pushing force produced by a solenoid is determined by blank. The number of turns in a coil, the amount of current through the coil, or both. Both of them.
Is Zach, is Bill still working here?
Bill Tate. He is still technically an adjunct, but he's not working this fall.
Okay. We just had, that was who we had for 133.
Yeah. Solenoid valves are available to control what kind of flow? Hydraulic, water, pneumatic, or all of them. You can use solenoids for all of those. What kind of solenoid valve blocks flow when the solenoid is de-energized and allows flow when the solenoid is energized? Normally closed. For a DC stepper motor, the amount of rotation is directly proportional to number of pulses. What kind of switches are small assemblies designed for mounting on printed circuit boards? DIP. Does anybody know what it stands for?
Digital interface. Yeah, nah, it's probably not right. But,
Me neither. Let's look it up. Is it in your book? Copenhagen? What does DIP stand for? Dual inline package. Duh.
okay.
That was my second guess.
That's because it says the 1 or 0 for it, right?
Yeah, dual overhead cam. Thanks, Cody. A float switch. You're like, will you quit calling him Cody? A float switch is used to sense the what of a liquid.
Double or height.
Height. Anybody have a sump pump in their house in their basement?
I think everyone in Illinois does.
I didn't in my old house, but a little thing that you pull up to make the pump turn on, that's the float switch.
Yeah, we got
So when it floats, it switches.
we got one that the operators always jack out of work on one of our heat treat lines, and it pisses me off.
Kill 'em.
Get in there and it's all smelly and nasty. And
Kill them.
good time. I was thinking about it. Push them into the quenching tank.
What movie is that from?
Switch that we can move from scrapyard to a new deck, and they moved the whole pump and everything, put it in the hole, and it didn't work. They're like, that's great.
Have you ever seen Saving Silverman?
Yeah, great movie.
You know, what's the is it Arlie Ermy or something like that? The old football coach guy. He was in Full Metal Jacket,
Not a great movie.
and Jack Black and what's that other dude's name? Come up to him and they're like, so we have a problem. There's this girl, and he goes, kill her. Snuff that bitch.
I second that.
Probably shouldn't say that when I'm on camera, huh? I think so.
Just do a little delete.
A little editing.
Oh, no.
Oh, whoops.
A little editing before it goes viral. What are drum switches used for? Starting and what motors?
Reversing, yeah.
Reversing.
But
I mean-
that could be used that to slow it down. You just kind of pop it.
Yeah, remember what that's called? Plugging? Trick question. But if you see it on a quiz, they want reversing. An actuator is any device that converts electrical signal into some kind of movement, mechanical movement.
I don't even have to think.
That is chapter 4. Now, for my next trick, I'm going to get a drum switch and show you what a drum switch is.
Take your second to get that one in. This side of the Mississippi. I'd be disappointed. Cute little lunchbox you got there.
Does it have her name on it?
Angle AB quality.
So, why is this called a drum switch? Because it looks like a drum.
I don't know if that's not a drum. Drums are round. You go boom.
It sounds like a drum. I don't know. They just call it a drum switch. But on the top, you can see it says reverse, off, forward.
I wonder if that's something to do with the energy.
Maybe it does.
You take it apart.
I will. Why are you yelling at me?
Sorry. You can grab right good.
Oh man, that sounds really good.
Last piece is all you there.
No. Hmm.
Chinese, that's all it's in. Where is that now?
So what do you think this thing does when it goes from one side to the other? It reverses how many of the leads? Two of them. And you can see inside there when I don't want to take this thing all the way apart, but you get the idea. 1, 5, 9, 9, 7, 11, 2, 4, 6, 8, 10, 12, 11, 12. Excuse my language. Anyway, you can see the contacts inside there. When I switch you'll be able to see those things close, hopefully. So it makes those, reverses two of the leads, and makes those on this side.
Seems a bit excessive for just a 3-way.
Oh, that's cool. Now I see. So this way makes 1, 9, and 10 and 6. And this way makes, that's off, they're all disconnected. 5, 9, and deuce, and 10. It's kind of cool. Anyway, normally like when I do this, I pass it around, but I don't think I should with Corona going on, so I'll just leave it open. You can look at it. Look at it. All right, so a lot of you are already past lab 1. Nobody's having problems with the power circuit, are we? When you hook this up and we close that disconnect, it's not going to turn the motor on, correct? Why? Well, there's 208 coming from the disconnect. These are open, right? So this is not a control relay. This is the motor starter. So somewhere else in the control circuit, we're going to have this coil. Hello. Oh man. Next door, 216?
Yeah.
Okay.
I'm working on it to try and get all the stuff for you.
Sweet. Thank you.
Any particular one other than that, I'm not gonna take the.
Well, Steve's using that room, so take all of them. I don't think it matters. Any one will be good. Thank you. So somewhere down in this control circuit, we're going to have a coil that just says M1. No. Yeah. What is that label? MS1, so motor starter one. Okay. So this is the motor starter coil. When this gets energized down here in the control circuit, these will close. So this set and this set are these, right? Really from here to here. And then the overloads control this normally open contact. Shit. This is lab 6. When this coil, motor starter 1, closes, it closes these, right? But if this trips the overload right here, it will open these. Make sense? So the coil is in series with this. If you're energizing this coil, we're bringing in, I don't know what wire number this is. 3, 4, 5. So wire number 5 come into this coil. And then you'd have a white 2 or neutral coming from here down to the normally closed overload. You see it says NC normally closed. So that when these heaters that aren't existent because they're not on there, but yours have them, if those get too hot to protect the motor, it will open these up, killing power to the starter coil and opening these back up until you do that after it cools off. All right. All right, push buttons. This normally closed contact kills power to the coil, right?
I get that, but the heaters are in the main 3 power lines, right?
Yeah, but remember, this ladder diagram isn't how this looks. It's electrical connections. So I've got power circuit coming here and here, and I've got control circuit here and over here, right? So anything I do to interrupt power in the control circuit will open these up, including the overloads. The overloads down here, when they heat up, they open this up, which de-energizes the coil. So either way you do it, if you de-energize the coil or open this up, which also de-energizes the coil, you lose continuity between this point and this point, which down here, these are going down to my motor, right? Does that answer your question?
Yes and no. I still don't see how the overloads connect to the heaters connect to the overload relay.
Well, and you don't see the overloads anywhere on this print. They're not on here. These are normally open contacts. Oh yeah, you are. Yep, you're right. There's the overloads. Remember I said they're not shown anywhere on there? They're right there. Why is that in series with, oh, is that what you're asking? So they're in series with the,
Basically saying, like I said, if those are what trip, how does it trip the normally closed overload contact control circuit? Because those are technically like separate from each other, right?
Yes and no. They're in line with each phase, right? So if it opens up here, it opens all 3 of them because it kills power to here. But let me show you. If I can zoom in there, there's a little tab in there that makes,
Basically, it's one of those other things where they call it essentially like the single phase the motor and draw more current on the coil.
no, it's really, its only job is to trip that normally closed contact. But when they're all in there, when all 3 of them are in there, there's a little spring, and I don't have, there's a little spring and there's a little spring on the back. So depending on what size this or heat value, this is a W35. I don't even know what that means. Right. So if that heats up, it starts to spin and it trips. There's a little tab inside of here.
Basically, it's just mechanically opening up that normal closed contact.
Right.
Any of those heaters get too hot to trip.
Right. I need to find a set of these that's old or something so they're riveted together. It would be nice to open it up and take a look at it. So it's a little easier to see, but
Might break one for you, Jay.
I know you could. But this is like a brand new one, so I don't want to break it.
How much does bad boys run?
I don't know. I never had to buy one. At least a few hundred. Let's look it up. Square D 509 BOD. We might need to know. It'd make you a good worker, right? If you knew what cost it was to buy a new one versus repairing one. Looks like about, hey, I like donations. About $300, depending on where you get it. Brand new for a motor starter like that. Still work? I wouldn't be surprised if it still worked. All right, I'll find a set of these and drill out the rivets so we can open it up and see the guts of it. But there's a little tab in there. You can see it down at the bottom. That's what actuates from the teeth of this heater. So when this thing heats up, it starts to spin, the teeth spin and hit that tab. And it's like it trips the relay. So anyway. This is a box of goodies. This is what's inside those junction boxes that you guys have. Is this a start or a stop? It's a trick question. It could be either. Doesn't matter what color you have on here, but these are handy because you can do two things at once. I'm going to show you the action of these, and this whole thing comes apart too. You can add more contacts, but there's a set of normally open and normally closed. This one's green, so I'm assuming you would use it for a normally open start button. But watch what happens when I actuate. There's a little plunger right in the middle, right here. And when I push, it will, right now there's continuity between these two. So if I wanted this to be a stop, I would use these two contacts because it's normally closed. These two are going to be normally open. So when I push the button in, you'll see that plunger break the top contacts and make the bottom contacts. You see that? So these two are set and these two are set. Normally closed, normally open. The stop button is going to have the exact same set of contacts. It might, some of them only have one, normally open or normally closed. But oh, I got it in there. You know what I mean? Whoops. So that's what your push buttons look like inside there. Yeah. Yeah, this would be one of those. Yeah, because it's breaking one set and making another set. Selector switch has the same kind of deal. A lot of them, and this is the only spare one that I could find, it's 3 positions. So on your print, and you see this is a selector switch. This says HOA because that's what I'm used to seeing, handoff auto. You could call it whatever you want. It could be forward, off, reverse. It could be green, off, red, whatever you want. The left side, because there's an asterisk here, there's an asterisk up here for left, which means when it's in the hand position, this contact makes, right? Down here is the asterisk for the right hand side, which means if it's an auto, this contact makes. And right now you can see that it's solid, not dotted straight up to off. So the plunger is in the tweener position. Same as what I showed you before, but this is what it looks like. So right now you can see that plunger in the middle is not making either set. It's just sitting in the middle because it's in the off position. But if I turn it one way, it makes one set of contacts. If I turn it the other way, so this is back to off, so it goes in the middle, and then to on, and it makes, or right, or whatever you want to call it, makes these two. Make sense? We'll do limit switches later. I want to get into control relays. So this print, I'm on lab 8. For right now, ignore IEC versus NEMA. We got two control relays, CR1 and CR2. So CR1 is going to control a set of contacts here and a set of contacts here. Some of you wired up control relays last time as opposed to motor starters, or maybe you did both. But here's what they should all look like. And you'll see a lot of these in this lab. Some of you figured this out already, but where's the coil at? Where would you land the wires for the coil? Right, so in and out. Same deal, just a wire going round, around, steel core, and in and out. Creates a magnetic field, and when this thing actuates, I put 120 volts on this coil, it'll create a magnetic field which pulls this in. So this does a couple things. It's an indicator, so if this coil is energized, you should see this in the depressed position. What this means is that every set of contact here has changed state. So when you see a set of contacts on a print, this is showing it in the de-energized position unless it says otherwise. So for this, if this was CR1, I'd be using two normally open sets of contacts. And on here, I have open, 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 and closed. So I could use any of these three. I know that if you looked at this before, if not, up here there's a tab on each contact, right? Here, that shows a picture of normally open or normally closed. On here, maybe I can zoom in. It looks like that. And then this far left one looks like that. And I'll zoom in and try to see if we can get a good picture. Can you see it or no? No. Kind of blurry. Oh yeah. Oh yeah. Oh yeah. Okay. So normally open, 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 and then this one's closed. But they're hard to see unless you got a zooming camera. But you can always. How could we check it? Continuity. So as it sits right now, de-energized, you should have continuity between this and this, right? And not these three. The other way to tell that they're different from each other, so let's say I knew this was normally open. You see how this is like got a little gray area. So this part looks the same as that and that, but this is different. I take this apart, you'll see why. These are actually interchangeable. So if I wanted to make this normally closed, I would take it apart, flip it around, and that tab says normally closed on the back side. You want to see? Believe me? Another nice thing about these Allen Bradley, any NEMA type, Allen Bradley Square D, NEMA, National Electrical Manufacturers Association. Have you seen that in your homework yet? Have you? Okay. That's like big, bulky. I love them because you can take them apart look at them, fix them, put them back together. If one set of contacts goes bad, you can get a replacement part for that. So this is what the guts of it looks like. You have to, if I remember right, yeah, physically take the contacts all the way out. Wait a minute, no you don't. Yes, you do. Yeah, so let's say this one I wanted to change to normally open. Just take that bad boy out and flip it around, you know what I'm saying?
You ever seen Trailer Park Boys? Zach?
I am a trailer park boy. No, I haven't. Okay, so this is a normally closed orientation and say, hey, I'm not using that, but I want it to be normally open. You take it out, flip it over. Bloop. Now it's normally open. You see what I did there? Fancy. Usually, in order to get it to work, you have to go bloop. So normally closed, normally open. All it is oh, there it is. Okay, so when that spring from the coil is pushing out on this, you can see this little contact right here is broken between there and there. So when it sits in there like this, and that spring is pushing up, it's made. If I flip it around and that spring is pushing up, it's broken, right? So it just depends on how I sit it in there, whether it's normally open or closed. So that is a contact. Put that back in, and I'll show you the coil. It helps when you make that sound when you tighten it up too. Boop. Mhm. Just remember, tight is tight, too tight is loose. Bloop.
No, I just, it was on a motor too. So we, I was a little upset after all that. We had no protective.
It's too tight. It's what it bolts.
Driveway.
Yeah.
I did not respond to Jerry this morning because if I did, I was going to
Oh,
literally
yeah.
jump down and smoke through it.
Jerry was all first.
He's pissing me off. Literally bitch about leaving shit out. He leaves shit out every single day.
All right, so there's your coil.
Oh.
It's a curl.
Yeah. On the back side of that is the spring. This is the coil. It's actually, it's in a figure eight. Okay, so it's in a figure eight orientation. It's inside this plastic. This is the iron core that it's wrapped around. So when that coil is energized, it creates a magnetic field that sucks that in with the spring on it. Right, so the coil is wrapped around this thing in a figure eight form. The spring is pushing outward, keeping it from making contact. And who had the trainer with the bad set of contacts? Yeah, I need to get that. So we were troubleshooting his because, and that's Cody. Did I get that right? Yeah.
So there. I'm Cody.
Derek.
Yeah.
Kyle. I'm totally kidding.
And
All right.
Yours. Paul is
Gorth.
He's not easily round enough and you know that. You got to do work to get this thing.
All right. So anyway, that's how those doodads work. So what's the difference between, other than this is making and breaking 4 contacts instead of 3, what's the difference between this and a motor starter? Overloads. This is a control relay, and it's considered that because it's making and breaking control stuff, but several different ones at the same time. There's another relay that's sort of a control relay that we call a contactor. Usually that's only making or breaking 1 or 2 sets, but let's say you had like a 30 or 40 amp like circuit of high bay lighting or something that you would want to control with, let's say it's like 277. You want to control it with something smaller, but the contacts themselves need to be rated for the amount of current that a big lighting circuit is going to draw. So I would call this a contactor. It's still a control relay, but it's only making and breaking 2 sets. And the action is pretty self-explanatory. Okay, so here, same kind of thing, right? Coil. Looks like this is the coil, and the core is on the outside. So there's a spring on here pushing the core away from each other. And when this gets energized, so here's the 2 ends of your coil, this sucks in and changes the state of the contact. Bloop. So, and you can see, nice and open, so you can see those things making and breaking. So you could call this a control relay or a contactor. You don't have these on your trainers. Dope. All right. That should be plenty enough information to keep going on your labs. So I will cut y'all loose now. Do some labs, work on homework, whatever you want. I have an appointment this afternoon. I should probably be out of here 2:30 or 3. That's cool with everybody. And then, what did it say, Wednesday? So Friday we'll come back in. You want to take a quiz on Friday?
I didn't know if you're doing it every 2 chapters. Like,
The quiz will be over the 4 and 5, but we'll go over 5 Friday, and then we're like way ahead of schedule already. I'm not really that worried about it, so let's just work as everybody is comfortable and not rush everything. Cool? Questions? All right. Make sure we're being nice to each other and sharing trainers so everybody can get their work done.
Zach, can you print me off another lab sheet?
Oh, geez.
I know.
Here's one.
Oh, thank you. That was so fast.
Mm-hmm.
I didn't even see it.
See that? Like grease lightning.
Like a ninja, an electrical ninja.